So, as just introduced, I'm Jim Thornton, and this is Luis with me. Luis is here to help out if there is any kind of Q&A at the end that's more technical. Luis is helping support on that here, and he's been doing most of the Neo4j related work for the projects that we've been working on relevant to this presentation. So we are Inbound Found. We are a digital marketing web development firm. We're about 10 resources right now, full-time resources. And we build analytics products with a focus on connected data to generate insights. Just a fancy way of saying we do a fair amount more and more recently with graph databases and website analytics and related inbound and outbound marketing. So we have 5 years, a mere 5 years of combined experience in this world. And, Inbound Found has been in business for 10 years. So we are getting LLM agents, and I should sort of caveat this. Virtuous cycle in this context means just trying to get LLM agents to work well with knowledge graphs, to create knowledge graphs, make data modeling decisions, extract text from places or pull it in from APIs, and ultimately get it into the knowledge graph, validated, enriched, and in a way that other LLM agents can use. And so we've been working on this problem. I know a lot of really smart people have been working on this problem, and that's also been clear in all the sessions here at Neo4j. And I would say for us, if you were trying to figure out where we fit categorically in the knowledge graph world, we are on the scrappier, we call them on-demand knowledge graphs, where we sort of spin them up and spin up parts of a knowledge graph enriched as needed, and then spin it down for what probably is more familiar termed as just-in-time knowledge graphs. But we're not so much on the enterprise sort of traditional knowledge graph side of things. We're just kind of figuring things out as we go. And so wanted to share some of the hard-earned lessons we've had, trying to roll our own. So the first case study to kind of contextualize the lessons that we've been learning is a project called Launch Guardian. And this is basically a project that's like Neo4j under the hood. We crawl a website before an old website, and then after a website launch or before a website launch for a staging environment, we crawl the new website. And we load both of those into a graph database, into Neo4j, so that we can compare network structure, we can run graph algorithms against it, we can look at information architectural changes, we can look at how internal linking might change, and talk a little bit more about that. But the goal is just to be able to uncover issues and identify opportunities and make recommendations to sort of ensure that a new website launch for thousands of pages goes well, instead of traffic falling out or conversions tanking or users having trouble finding what they were looking for, which are all just common problems when there are so many moving parts in website launches. So our very kind of simple data model here is you've got your crawl node, and when we run a crawl, we will store the status code of the URL. If it's if the web page is there, it's a 200. If it's a redirect, it might be a 301. On the URL node, we store all the content in markdown format on a property, as well as embed it. And we also store the TF-IDF, just in natural language processing. We try to identify what unique keywords we can extract from that page relative to the rest of the website. And we also use that for, it helps us with cosine similarity, which I'll get into later. And we have hrefs links for our more, expressed relationships. And then we can infer relationships between pages, even if they're not internally linked, based on Google Search Console terms or keywords that we extract from the web pages, and then do some topic modeling to do, keyword clusters to pull those together. And something worth noting, the crawls are versioned. So it's sort of how we handle temporal things there. And the Google Search Console data, think of it just like the website analytics data, is time series. So we bring that in daily as relationships between URL and the term. So if someone searches something in Google and clicks on your result and ends up on that web page, we have that psychographic search intent from the user landing on that web page mapped into the graph as well. And then you can see that we also have some user inputs where we might ask the user what's important about this website, what topics are important, and they can input that. So one of the reports we have, and again, I'm just trying to provide some context, and I'll be speed this part up. But this is redirect analysis, and so this is a website that has about 60,000 pages, and they recently did a new website build that they launched, and here you can see. It's a little hard to see, but here you can see this homepage node has a lot of old URLs redirecting to it, and some of them are green, which is good, and some of them are red nodes, which is not so good. And so in traditional tools, you would just check that all your 301s work for thousands of pages, and you would say, okay, great. But now, right, with vector indexing in Neo4j, we can look at cosine similarity between the old page and the new page and see if it actually is sending the user, right, are we redirecting the user to places that they should be going? And we can, peel back the curtain a little bit more and see that, oh, okay, this web page used to be linked to by thousands of pages, and now it's just redirecting to another page that's in fact orphaned and not being linked to anywhere on the new website. So we can just kind of quickly uncover issues like that. On the topic modeling side of things, and we do a fair amount with BERT to generate these, and KNN and Louvain, is that right, Luis?
Yeah, right. We're using KNN to generate the connection between the similar nodes, then Louvain to actually label them as communities.
Perfect. And so with that, what we're able to do is take a time series, maybe 2 months before a website launch and 2 months after, cluster all those terms together, tens of thousands of terms into their related topics across pages to figure out how much better or worse they're doing in terms of traffic from search engines. And so you can see like big and red is bad and green is good, and this probably looks terrible. But the click difference here is sorted by the worst ones. I wasn't really thinking when I did that, but you can see, okay, we've lost 10,000 clicks on this subtopic. And so we can quickly drill down into that, sort of see what the issues is, and then bring in LLM agents to compare old pages to new pages and make like more specific recommendations on a page by page level, and maybe aggregate that if there's some templating issues or other things like that. So you can see how sort of becomes useful for us. So anyway, lessons learned working on Launch Guardian and trying to figure out LLM agent things. So get the data model right and well part of it. So what we've sort of learned, or what we're applying in these two projects now in terms of thinking, is we have a core protected data model with the constraints like very carefully laid into it, and it needs to be described just so, with really good testing for LLM agents to just sort of make sure that they understand exactly what we're doing, what the goal is behind it. And so I guess what we would just want to say here is, won't always get the data model right to start. And even if it is right for humans, right, like you're using domain experts to sort of determine your ontologies and those types of things, it might not be optimal for an LLM agent querying it. And so there are ways that like we've figured out to work around that. So here's an example, right? This is like a very simple, just in the Arrows app, layout of like, hey, here was a crawl and we crawled this URL, and now this old URL redirects to this new URL, and you can see the crawl number is 2 for this property. And it's clear, and it was hard earned for us to get to this point, to be honest, but the LLM just needs to know this, right? Like they just need to be able to see the old page and know that we're trying to compare the old page to the new page, right? And so there are ways that we can just be a little bit more pragmatic and like simplistic in what we decide to end up ultimately passing. And this was, I think this is very popular when it came out, April 2024. There was a paper released, a study where you can see in this figure that 40% of the inputs to the model were affected by noise, and that was things like grammatical mistakes and typographical errors. So when I go back to this, I think any of this is potentially noise. Anything that's not sort of summarized or compressed down into or reduced down into just the pure meat of what we want to do is a liability, right? And introduces risk to our pipeline. Okay, so last year we did a lightning talk, and we were we were excited about this, which was like talk to your website, right? And there was a talk earlier, like a fireside chat type talk, and someone, I think Ashley Faith maybe, had said like, oh, hearing that like, oh, like talking to your docs is like so 2023. And so it's just funny because that's where we were. And I remember being really excited about this. But even if you like read this, it's like, how many redirects does the homepage have? Oops. Like, please count the number of redirects on the homepage. It's 25, but it wasn't 25. It was just phrased awkwardly. And at least for us, the chatbot use case was a bit of a distraction. There were too many unknowns for us to sort of sort through what we needed to accomplish with LLM agents in our graph. And so the goal was not to chat, right? The goal for us was specifically like, how do we improve recommendations for big, complicated websites that we're loading into graphs and comparing network structures. And so I think it's maybe sounds obvious, like, and it looks obvious as I'm reading this, like on my screen. But the goal needs to exist before and be defined very clearly before even getting started, right? Like, why are we building a knowledge graph? Like, why are we doing knowledge graph things? And why are we trying to get LLM agents to communicate with them besides them just being cool and fun? And so the goal being needing to be clear, simple, and actionable. When we were looking at sort of our redirects report, I can have a table of prioritized redirects by issue with some score, but it would actually be a lot nicer if I could bring in a redirect pattern analysis to identify, oh, like this subdirectory, all those URLs actually should be going here instead of there. And so anyway, time just is like a river that just flows by me. So anyway, have easy way to isolate what you need. And I think this is, as I say all these, I'm like, okay, I know people know these, but these were like hard-earned lessons for us. We want to have a way to isolate the relevant parts of the graph so that the LM agents can get the context that they need and nothing more. And I think that's that is quite tricky, or it's been quite tricky for us. And so a couple ways that we've done it successfully is assigned a shared label to what we want to isolate with like a label-based access control, right? Like kind of like RBAC, but LBAC. And so we can, exclude other websites if we're running PageRank. That should be tucked under the GDS one. There's a lot of things that we can do. And as long as we're sort of isolating the graph in some way, we can be more bold. And because it feels like bold and risky to like allow an agent to do something to my graph, right? And so the other ways that we can do that is we can limit the number of link hops that it can go to and the types of nodes that it can query. And of course, there's Neo4j has native projection, right? And so we can always project a graph or use a graph in memory. The other tool, quote unquote case study, is a project that we're working on. This is a newer project, it's less mature. And it's basically pitch tooling to research prospects or contacts, identify common ground between you and them. So your sort of data is loaded in and their data is loading it in to do cold outreach or warm outreach on a shared contact based on shared contacts and connections. And so there are a lot of Gen AI startups in this space. And there's a lot of automating personalization at scale where it's like, I noticed this obvious thing on your LinkedIn profile. And that's like the icebreaker, right? In a cold outreach email. And we're really not trying to do that. What we're really trying to do is identify the most likely points of connections between two people, so that we can surface them so that the person has more time to be human in that situation. So here you can see we have more of a knowledge graphy feel to our data model, and we do have some sort of protected, quote unquote, entities like in our ontology that we think about. And you've got like skill, work skill, company, job title, sort of like LinkedIn type things that you might imagine. The person. SERP stands for search engine results page. So if I run a search on, a famous author, what are the top results from that search engine's results there, and what's in those articles, right? And so we're, doing some of that type of extraction as well. So lesson learned, think deeply about how to describe the knowledge graph to the agents, but like don't. So this is sort of fun. I got on this kick of thinking, okay, the web is, using schema.org, and for entity naming conventions, and that's in JSON LD, like JSON linked data. And there's Shackle, which is like a standard specification for constraining, properties or putting constraints on our schema. And so I can just, pull everything out of Neo4j, and I can, ask an LLM to convert it into JSON LD with Shackle. And I can, do all of these things like, take the dump, and here's step 1, and you are tasked with this. And step 2, you need to parse this. And step 3, you should just define this context. And step 4, do this. And then, I've got to validate like the Shackle shapes, right? And like return that. And then ultimately, like I get something that like kind of looks good, but is just completely unreliable. And I spent days on this, and really like simpler would have been better. So, okay, we are doing good on time. I'm like doing the math here. Okay. And this is quite obvious maybe, but so if we're, giving an LLM agent and we're saying, hey, match on this person, we wanted to understand the graph and like what exists in the graph. So we started by doing something like this, like a pretty straightforward query, just to get, the count of relationship types and nodes off of one node type. So this is like all the relationship types that exist in the graph, and the connected node, the connected node labels. And you can see the counts of them to sort of get a sense of like, well, when does it start getting sparse, or what relationships are more sparse than others? And the LLM agent that we were working with on this, I know how that sounds. I don't mean for it to sound that way, but the system instructions that we were using, it actually performed better to put it in this format and then just sort of say, like, here's the format, instead of like just doing comma separated. And a small optimization like that actually ended up making like a pretty good difference in LLMs being able to quickly have enough of a sense of the graph structure that we have. So these are user inputs that we have, and the user inputs we had to think pretty carefully about, because whatever the user can input initially, when you're allowing that input to affect the shape of the graph as well as the expanded ontologies, which is like what we've been working on. So I want the user to be able to say, here's my goal. I want to do this thing. And then I want the LLM agent to say, okay, your goal is this. Here's maybe a strategy plan. Here are potential ontologies like that we can use. And here's the type of data that we would need to collect to get to a rich enough insight that we could push that back. So we're sort of dealing with these prospect profiles, right? And we're doing some pretty simple vector embedding on the ideal client profile, and just running cosine similarity to return a result of good fit recommended matches for contacts. And then the campaign goal is sort of where a lot of the work in how the knowledge graph gets built and sort of spun up on demand happens. So this actually came from going back and forth with like Claude Sonnet 3.5 on knowledge graph expansion pipeline plan. And so here we basically provide instructions to the knowledge graph on how to architect, or I'm sorry, to the agent on how to architect the knowledge graph by starting with the campaign goals. And we ensure that any questions that could be used to clarify get passed back through as a form to the user. So if the user inputs their campaign goals, the next page that they get to should be a form of inputs that are basically requests from the LLM agent of things that would be sort of helpful, right? And we can kind of guide that with system instructions as well. Then we have this ontology expansion where we're analyzing the goal, human input survey that I just mentioned, doing pattern recognition and trying to extend the schema. And then we're looking at the protected schema layer and comparing it against that to see how it might better fit. And then we have another LLM agent basically take that ontology and determine how likely or unlikely are we able to collect the type of data that is getting what's the term? The type of data that the original LLM agent was requesting. So for example, we have a use case of a mortgage company. They have 500 mortgage brokers. Those 500 mortgage brokers want to be able to better network with, say 25,000 agents, real estate agents in their area to get referrals for loan origination. And so which realtor should be matched with which mortgage broker, right? Like how do we match those people up? And so it might infer that we need market trends, or it might infer that we need listing data on a per agent basis, but it might not be realistic for us to go out and get that. Or we might have to, human in the loop, create a pipeline for it and add that tool to the toolbox for the agent. So I'm going to skip forward. If the LLM can alter the data model, leave a trail. And I think that is a good spot to do that. Excuse my mess. Good spot to kick over to Neo4j. So this is, again, the data model that we were talking about. We know that. This is two connected people. This is me and my brother, our LinkedIn connections information. Oh, gosh. I guess before I start doing all this, I should think a little bit more about... I've practiced this, and I knew to pull my nodes apart before expanding them. Okay, so this will give you a sense. That's not right. What happened? Oh, okay, yeah. This will give you a sense of how connected we are. And we're mostly connected through people. We're actually not connected through skills, shared skills, or anything like that. I'm just gonna skip ahead. What relationship type counts in network ICPs? Okay, let's do this. So here I'm just doing, a query, angel investors and AI startups. I want to see who in my database of contacts, which is my contacts and my brother's contacts and who in my database of contacts fits this ideal client profile. And basically, we've done a vector embedding on a couple sort of summarized down properties of like headlines and job descriptions and even like career trajectory type stuff to get to this point. And you can sort of see that, it's not too bad. And I can also look at, in pretty simply in my shortest path, shortest path, that if there is someone that is not in my immediate connection, right, I can see who is my closest connection, right? And in this case, it's my brother. And so let's move on to the next one. So this was what we were just going to keep it clean. All right. So this was that example I gave of if we want the LLM to have access to like something with edges on it, we can just label everything that thing. And we use this in our testing and validation. So basic enrichment to them. And we've looked for the overlap, right? And we've also gone to, I'm going to get I'm going to get in trouble here because I've lost where the articles are. Luis, help.
Yeah.
Oh, here.
Can you check?
Okay. So that is an article. I feel like we changed the colors on the nodes, and now I'm like confused by my colors on the nodes. So one second.
The best way to get the articles are, can you run it again? The query. Okay. Then look for the chunks. Can you expand some?
Yeah, let's expand. I think we can like describe this as well. All right. Help me find.
Mention in the graded one.
Then
Those are the chunks. When if you expand that, you get the article.
Okay, cool. So what's happening here is we're taking contact that is like an influencer in an industry that has some information, like publicly available information about them, and we're using like a SERP API, and we're running a web search on something related to that person and some topic, right? Some relevant topic. And then we're returning articles. We're using unstructured IO to chunk the articles and to put those into chunks. And you can sort of see that we're just using like a pretty common, I think, structure that, like the Neo4j community is so great at sharing things, but we're using this structure in our data model. And then we have them and me. I feel like the best way to visualize this is not live doing these things. Where did I put it? Okay.
There you. Yeah.
We did it.
See the overlaps.
So the overlap looks better, but generally speaking, the overlap that we had for like immediate overlap without these was, so here, I'm going to actually run it again just because it's a little bit unclear. Oh gosh, time is a ocean. Anyway, what I was going to show was that there were maybe like 2 or 3 things that we had in common, but then there were a lot of skills that we could have determined would be, wrapping it up. Okay. There were a lot of skills in there that we could have run cosine similarity on to determine more overlap, because there was a ton of overlap to be had. It just wasn't expressed in the graph database the way that we had loaded the data in. And so once we realize that there's sparse data, or that there's a connection that we're trying to make or we're trying to infer that doesn't exist, we can just pass that over to the LLM agent to just go and start trying to make those connections, determine, hey, is this career trajectory similar to that career trajectory? Do they have, overlapping skills? Do they have skills that like would work together well? And anyway, that's our presentation. And I think if people have any questions, we're going to say, Luis?
Yeah.
I think that's about it. Yeah, we are done. And I will skip that. Okay, we did it. We're done.